just like you need to be familiar with history in general, you need to be familiar with computing history specifically, especially if you're going into a computing related career or an IT career, because people will mention some of these things and you won't know what they are, and they'll think that you're not very smart. So we're going to do a brief overview of the history of computing, and it goes back much farther than you might imagine. Mankind has been trying to come up with a way to make tasks easier, automated, to do calculations faster and with more accuracy for thousands of years. This isn't something that's just come up with Bill Gates and Steve Jobs. Although they may be the figures that you're familiar with, there are many people throughout history that have been interested in and have tried to come up with devices similar to the modern day computer. So we're going to talk about a few of those. So just as with any subject, it's good to know the history. As I said, these aren't a new idea. We've been trying to mechanize things for a long time. And then we're going to take this information and we're going to turn it into our project for the quarter, where we're going to have an interactive application with pictures and buttons, and you can click on a button about one of the objects and pictures and text will appear, and then click on a button about one of the other devices and the ones that were on there will disappear and the new information will appear in its place. So we're going to do like a little interactive program that hopefully we can compile into an executable so you can take home and show your parents. So when we start talking about the history of computing, we consider the early devices in the category of mechanical devices, and these are the forerunners of the modern day electromechanical computer, or the electronic computer that we have today. So early mechanical devices that were used to help with calculations. One of the classic examples is the abacus, which was used for counting and arithmetic. It was used in trade to figure out how much people owed each other, at the dawn of time. So we go from that device, and you may not be able to find the specific creator of that, but certainly when you're doing the research for your presentation, you can find out the rough time frame when this was used, and you can find a description of it, and there are lots of pictures of those out there that you can find. So we go from that type of very simple early device, and mechanical in the sense that it had moving parts to it that someone had to manipulate. And so we jump ahead from that ancient device up into the 1600s, where around 1642 the mathematician Blaise Pascal invented a device for calculating, and he called it, appropriately enough after himself, the Pascaline. Now it could add, it could not do division or multiplication, and it used gears like a clock, and this is what it looked like roughly, and you can see the gears in the picture. And of course he was a French philosopher and mathematician, and this device had a very complicated set of gears that operated much like a clock, as I've mentioned. However, think about the problems that he had in developing this device. There was no assembly line mass production with standards so that each gear was to a certain specification, so that each gear, whether you were making 1 Pascaline or 1,000, that all the gears were the same from device to device. There was no consistency because these were actually manufactured and crafted by hand, and so it was very possible for each gear to be slightly different. So you had consistency issues in the manufacture of it, which affected its reliability. It was not necessarily the most reliable device because of the fact that there was no way to standardize the production of the components for it. So if you're interested in how it worked, you can certainly go to this YouTube video and check it out. There's some good information there. So he invented that around 1642, And then later on in the 17th century, another mathematician decided he would create a device, and his goal was for it to add, subtract, multiply, divide, and do square root calculations. And he called his device the stepped reckoner, and this came out around 1673. And this was created by Gottfried Wilhelm von Leibniz, if I'm pronouncing that correctly. And it used a cylindrical wheel. Here we have a picture of this stepped reckoner machine, and it was another early attempt at creating a mechanical calculating device. It had a movable carriage. You could enter digits for adding, subtracting, multiplying, etc. Again, much like the Pascaline, it was mechanically unreliable. It would jam, it would malfunction, where again hampered by the lack of assembly line type manufacturing that makes every device the same. This would have been handcrafted, so there was the potential for variation between each stepped reckoner that was created. And so we leave the 1600s and we jump ahead to the 1800s, and one of the most noted early proponents of some type of computing device was a man named Charles Babbage. And in 1822, he began working on something he called the difference engine. Now, his goal was to produce ship navigation tables without errors. And so when ships would navigate, they would use these tables, and they were based on mathematical calculations that people were doing by hand, and they were very inaccurate. They were very prone to errors. Well, of course, if you're depending on that to navigate, you could get lost, at sea. You end up somewhere you're not supposed to be, that you don't intend to be. So that was an issue at the time. So Babbage proposed this machine that would do all of the calculations without human error. And of course, I've got a link here, and that's actually a very good link. There are lots of interesting facts about this machine and Babbage and how he planned to have it work. Now, he never actually built this, but he laid out all the plans for how it would be built, and one of the computing history museums has actually built a replica of it, and that is what you see a picture of. So the difference engine, again, it was never built, but it also inspired Babbage to continue on with another idea that he had for another device called the analytical engine, which he began working on in 1833. Now, this analytical engine was going to perform more than just ship navigation calculations. It was, in his mind, it was going to perform a variety of calculations. And the key here is he visualized his analytical engine following a set of instructions that were stored. They were going to be stored on punch cards. And now we have the beginnings of the idea of a computer program, stored instructions that a device will follow. And he also proposed the idea that this analytical engine would store information in a memory unit as it was running. So it would have the program on punch cards, but it would have another memory unit so it could store intermediate answers to mathematical calculations, and so that it could make decisions and carry out instructions based on decisions. Okay, so here we have the early idea of an if statement, something that we will be learning about later on. So he came up again with an idea, but it was never built. He planned it out, he drew out the blueprints for it, but it never actually got built during his lifetime. But it is really sort of considered the model for the modern computer, the idea of a memory unit, the idea of a set of instructions that can be followed. Now, Babbage worked on this with Ada Byron, who was married to Lord Byron, I think the poet. And she is actually considered to be the first programmer because she really bought into this idea with him of the idea of a stored set of instructions that could be executed over and over with some variability because the machine could make decisions and comparisons and so on. And she actually, based on his specifications, wrote some programs for this proposed analytical engine. And you see a replica of it here. You see where it's been built much later in our time based on Babbage's plans. So Ada Byron, Countess of Lovelace, and actually I'm sorry, she was the daughter of Lord Byron. She was very interested in mathematics, and she was one of Babbage's sponsors. She realized the power, the significance of this device, and she really tried to help him get funding for it, but they were never able to actually build it. Babbage also thought that eventually these machines would be able to think on their own, the idea of artificial intelligence. He and Byron, Ada Byron, disagreed on this. She believed that a device like this would never be able to originate anything, meaning that she didn't think any machines would ever be able to think, and so far that is still a true statement. Now, one of the early computer languages, Ada, is actually named in honor of her because of her contributions. So here is some additional information you can follow up with on YouTube that's pretty cool about Babbage. And a little bit of trivia. The reason we call these devices today computers is because the people that perform the mathematical calculations that these devices were meant to replace were called computers. The guys working in the shipping office doing the calculations for the navigation table, their job title was computer. So that is where the name for these devices came from. It was actually based on the title that the people who did mathematical calculations during those times used. So I've kind of given you a start. You can see where I put my presentation together. I put the devices in order chronologically. I have gotten one picture for each device. I have given facts about the device. I've tried to come up with who created it, what it was meant to do, a description of it, and so on, which is what I've asked you to do for your assignment. So I've asked you to create a PowerPoint. Now I'm flexible, any type of multimedia presentation where you can put pictures and text in, because I didn't think about the fact that you guys probably don't have PowerPoint at home. But you can use the Google version of that, OpenOffice. If you're on a Mac, I'm sure there's some version of that if you have it. I just would like to see something other than a Word document, if at all possible. But of course you can simulate slides in a Word document as well if you're forced to do that from home, because you may run out of time today and tomorrow. So I would like for you to use the remainder of class today to flesh out and finish out and do the research on the other devices that are just as important. Now I've given you the abacus, the difference engine, the analytical engine, the Pascaline, so I've given you the stepped reckoner. I have given you a lot of these, but you need to go out, do a little bit of research on your own, see if you can come up with some additional information on the devices that I covered. But you're also going to look for things on a device called the ENIAC. You're going to look for Hollerith's tabulating machine. You're going to look for the UNIVAC. You're going to look for the ABC, the Atanasoff Berry computer, and you're going to look at the EDVAC and the EDSAC. You're going to find some of these actually had military uses, or they were trying to use them, particularly in World War II, but they were not always successful. You should be thinking about, on some of these later devices, the size of the device would be interesting. Did it generate a lot of heat? Was that an issue? How was the thing how did it look? How was it built? How many rooms did it take up, etc.? So those are facts you should be looking for in addition to the other things. Approximately when it was invented or created, give a brief description of it. What was the purpose? Like shell trajectories was one of the purposes. Census tabulation was another for one of the other devices. Who invented it if known? Were there any problems? Heat, size, unreliability,